Hello my friend, today we're going to talk about the minilibX. This is going to be super practical and I will keep the theory as little as possible. The bare minimum to understand the first principles that we need. So what is the minilibX? So you search minilibX and you will find on GitHub this repository, right? In 42 parties. Of course, this is a mini library for students. As you can see here, you have all the C files. This is not very long. And as it is written in the README file, is a simple window programming API in C, designed for students, suitable for X beginners. What does it mean? Well, long story short, my friend, this is an API for the X window system. The X window system is a windowing system for bitmap displays common on Unix-like operating systems. X provides the basic framework for a GUI environment, drawing and moving windows on the display device and interacting with the mouse and keyboard. Okay, you can dig as down as you want, but you understand the main idea. Basically, the X server is a program that allows to do graphics, right? To draw stuff on the screen. Here on Wikipedia, you have this marvelous image that explains basically everything you need to know. As you can see here, you have the devices, the input devices, which are the keyboard and the mouse. Then you have the computer, which is this square here. Inside you have the X server. So you have this piece of software that is acting as a middleman between the input devices and the applications. So the X server is mediating the inputs coming from the input devices, such as the keyboard, when you press a letter, for example, and then is sending these inputs to the clients, namely the applications. Then the applications will perform the necessary operations, and then we have the input back to the X server that is gonna show in the screen the result, right? So the X server is that invisible middleman, invisible program that allows stuff to be seen on the screen, okay? So I know that there are different implementations of this program, but the most famous, of course, is its.org that you can find here, its.org. As you can see, the Xorg project provides an open source implementation of the X window system, you see? You can check by yourself. So the communication between the clients and the server happens thanks to an interface, which is the xlib library. This one, x.org, it's lib C language, X interface. So this is a big boy, as you can see, right? It is explaining all the things such as drawing stuff, drawing single and multiple points. You have all the functions here. For example, let's search for display. Here comes display function, opening the display. Here you get the prototype. This is a data type display, the function, the input, and so on. So this is a big boy, right? It's a big library, and it's very tedious to learn all this stuff. Thankfully, we can use the minilibX, which is just a library which is built upon this X library, you see, xlib. Indeed, inside the minilibX, you can find, for example, the destroy display. Let's watch how this function is implemented. Here you have mlx destroy display, which is xclose display. So xclose display is indeed this function, as you can see, that is taking as an input a data type display. Indeed, as you can see, this is what happens, right? So here you can clearly see how the minilibX is just an API, an application programming interface, a simplification of another library, because this function is basically calling this other function, which is part of another library. So TLDR, this minilibX is just a mini library built upon the X library, which is a library to speak with this big boy here, the X server, which is thought for beginners because it is easier compared to this X library here, okay? This gigantic page. If we had to understand everything that goes on inside this page, we would become crazy, right? Just for your personal culture interested, we have another project that is taking place, which is Wayland. And Wayland is, as you can see, a replacement for the X11 window system protocol and architecture with the aim to be easier to develop, extend, and maintain. So again, you can dig down as you want. So my friend, this is my super quick introduction. Now we talk code. Now we talk practice. So immediately I'm working on a Mac, so I need a Linux machine. What shall I do? Well, I'm gonna use a virtual machine. Basically, I'm gonna use a fake computer, a fake Linux computer. So I'm gonna open VirtualBox inside VirtualBox, I already have my Ubuntu machine that I'm gonna start. If you don't have a clue of what I'm doing, just watch this video, my friend, which is from Livia Lima. By the way, I highly suggest this channel. She talks about Linux machines. She is very good. And specifically for our purpose, we want to create a local Linux server in a VirtualBox. So just watch this. Here it comes, my friend. As you can see, I have my Linux computer, and here I have my macOS system. Now, the problem here is that when you work on a virtual machine, everything feels very clunky, right? Everything is not very responsive. So what I'm gonna do is just to SSH inside this virtual local machine. So I'm gonna work in my macOS like that. And then I'm gonna simply SSH inside my computer. So I'm gonna do SSH, the name of my Linux machine, and the port by which I want to SSH. Again, if you don't know this stuff, just watch the video I showed you. This is stuff that you shouldn't know. I'm just doing for making everything more fluid, right? Because basically now I'm inside my Linux machine, as you can see, right? I'm inside my Linux machine, even though I'm working on my macOS. So we start. I created some exercises to make it super simple to understand the key ideas. We start from the first exercise, which is an introduction, and let's watch what I did. Okay, this video builds up on the previous video that I made, in which I talk about rendering on the screen polylook. I suggest you to watch that video so you can have a better understanding of what is going on here. So every time I want to render something on the screen, I have first of all to connect to the server, right? I have to establish a connection with the server. This is done by the function mlxinit, right? What is this function doing? Let's watch directly through the implementation. So I go on the minilibX and I search directly there what is going to happen when I call the mlxinit function. So I have mlxinit. Boom. I'm gonna search and I find directly the code where this is implemented. As you can see, there is a lot of stuff going on, right? The mlxinit is all of this baby here. We, of course, abstract away this mlx function like connecting to the X window server, but there is a lot of going on. Indeed, we can see immediately a malloc. This malloc is important because every time we have a malloc, we need to use a free. So we need to know what is going on. Indeed, we have a malloc of an xvar variable. So let's search this xvar. Again, we find this, right? So as you can see, inside this xvar, we have many things. The most important one is this display. We have a pointer to a display. So we have that when we call the init function, we have a pointer to this object that indeed contains a display that is obtained thanks to this function, which is xopenDisplay. Let's search for it. xopenDisplay, what is that? Well, this is a function, of course, that we can find inside the X library. Is this one, xopenDisplay. This is really important because the xopenDisplay functions returns a display, so structure that serves as the connection to the X server, as you can see. So that's why we say that the init function is gonna spark the connection to the X server. But as you just saw, there is more to it, right? The init is not only doing that. What is really happening is that this function creates a structure and returns the address of a struct. Indeed, you have the return of the xvar, which is this struct here, right? This is a struct that contains all the stuff the minilibX will need in order to do its things. Okay, so I call the mlxinit, and of course I have to check if the pointer returned is null. Indeed, here if I have some problems with the xopenDisplay, I have returned a null pointer, you see? So when we deal with pointers, it's always good practice to check for null. Here basically I have a copy paste of the code that you just saw. I will push this stuff on GitHub, so if you want to play with this code, this is going to be pretty useful. And here again you have the copy paste of the xvar. As you can see, you have screen, depth, a lot of variables which are useful for the connection. So long story short, what is the take-home message? You get a struct xvar which is malloced in the heap, okay? And inside this struct you have a display, which is just another big struct that contains other stuff. As you can see from the X library, the xopenDisplay returns a pointer to a display structure, which is defined in this library. Otherwise, it's going to return a null. So why it is interesting for us? Well, the display is just another big struct that has to be freed, okay? So let's make a TLDR. I call the mlx function, In my mind, I establish the connection with the X Windows server. What is really happening is this. You get a lot of stuff that is happening and you return an X var struct that contains all this stuff. Inside this, you have XOpenDisplay, which is a function coming from the xlib. So you have to keep in mind that you have a display now. Therefore, you have to free the display before finishing the process if you want to exit in a clean way. For that, we have this function, which is mlx destroy display. Well, you probably guessed it. Here we are. mlx destroy display is just an API for xclose display, which is just another function that you can find inside the X library. Of course, this is just a function that is gonna clean all the stuff, is gonna free all the stuff, right? The xclose display function closes the connection to the X server for the display specified in the display structure and destroy all windows, resources, and so forth. Basically, it's a cleanup function. So here, as I can see, I'm gonna destroy the display and then I'm gonna free the mlx pointer, which is just a struct that is containing also the display. So this program absolutely does nothing, but let's compile it and understand some ideas. So to do the compilation, what shall I do? Well, here I have all the exercises that we are watching together, and then we have the minilibX. So I'm gonna cd inside the minilibX, and we're gonna launch make. This is gonna compile and create our library that we can link to our C files. As you can see, now we have libmlx-linux.a. So this is the archive file that we're gonna need. So we cd back and then we compile. The compilation is done in this fashion, my friend. As you can see, we have to link. Here you have the upper L that stands for the path to the library. So this is a path. Here we have the little l that stands for the name of the actual library. Here I made you a file in which I explain everything related to that. As you can see, LX11, this flag is for linking the X11 library, which is a graphical, you know, all this stuff. And this XEXT is for linking against another library which provides extensions to the X Windows system. So basically, you can read the stuff by yourself, but keep in mind that to do the compilation, you need all these flags. Okay, so we compile the exercise 0. Now we're going to launch. Of course, nothing really happens because the program is just initting a connection and then freeing the display and freeing the pointer. Now, TLDR, what I want to show you? Well, I want to show you that if I run the code as it is, so now I'm going to save this and I'm going to run directly into my virtual machine. So I'm going to compile and I'm going to valgrind this. As you can see, I don't have any leaks. If I comment this mlx destroy, I compile and I valgrind this, and now I have the leaks, right? I have 91 allocs, 53 frees. So I have some leaks. I uncomment this again, and at the end, I'm gonna just comment this free mlx. Let's see what happens. So I'm gonna gcc and I'm gonna valgrind. Again, I have a leak, 94 allocs, 93 frees. You see? So to remove this, I have to free also the pointer returned by the init function. I'm gonna save, again, compile, and then valgrind out. Boom, all leaks were freed. No leaks are possible. So long story short, when you call the mlx init function, you're establishing the connection to the mlx server, but you are also mallocing this big struct and the display, okay? So keep in mind that if you don't want to have leaks. Okay, let's pass to the first exercise, which is window. Basically, this time, my friend, we are creating our first window. So, of course, we include the mlx.header file. I have some symbolic constants here, and then we start. Void mlx connection. This is the pointer returned by the mlx init function. As you can see here, I have this mlx init. Of course, I have the check if the return value is a null. This is always a good practice. And with that, you know that I have established the connection. Namely, I have this big struct that contains also the display. Now I want to create the window. What is the window? Well, the window is just another big boy mallocked, okay? No surprise. So if I search mlx window, I don't find anything. I have to search mlx new window. mlx new window. Here it comes. I have the prototype and the implementation of the function. mlx new window is going to declare this new window, which is a type window list. And here I have the malloc, as you can see, right? So just another struct that we have to take care of. At the end, it's going to return new window. So the API that we have is this one, MLX new window. We have to pass the MLX connection, height, width, and the name, the string that we want to see in the window. Of course, I have all the time to check if null is returned. In the case is returned, I have to destroy the display you saw before to free the MLX connection and to return malloc error, which is 1 in our case. Okay, now we have a window in which we can draw stuff, right? So by now, I repeat to you, we have only MLX init and MLX new window. These are the two functions I use. All other things are just control code here and a lot of comments. Let's try to launch this code. So I'm going to compile and launch. As you can see, nothing happened. Of course, I need a loop that keeps alive the program, because I have the window that is being created, but immediately we reach the final curly brace that is going to end the process. So here I have an event loop, as it is called, which is this function here, mlips loop, and I pass as an input the MLX connection. Basically, this is a function that keeps the process alive. Let's try to save and launch again. So I'm going to compile and launch. As you can see, I have my window, okay? So this is what happens. Thanks to the loop, which is still running, I have my window that is alive. Now I can simply press Ctrl+C to end the process. So this is an event loop. Without this loop, the process will stop immediately. Why this is called an event loop? Basically, this will kick a loop in which our process keep listening for events. Events are stuff like clicking the mouse or clicking some keys on the keyboard. So here at the bottom of my file, I have, of course, the cleanup functions, right? Destroy display, destroy window, and free. But I will never reach this point because the loop won't allow the code to reach this point. So what do we get? Let's try again. I'm gonna launch the code again with Valgrind, it out. I have my window, and then I click Ctrl+C. But I get some leaks. So of course I need events handling for that. So we have to manage properly this stuff. Before passing to events, I wanted to show you that we can have multiple windows in our program. Let's very briefly watch this program. I have my MLX connection, which you already know comes from the MLX function. And then I call 2 times the MLX new window. I call it here and here. So I have window 1 and window 2. This is just control code for when we have a null pointer coming back, you know this stuff. And then I call my MLX loop, that is keeping the process alive, listening for events. I'm going to save and launch. So I'm going to compile and launch the code. As you can see here, I have 2 windows. Okay, so that's basically what it is. We can have multiple windows to handle. Okay, let's close, Ctrl+C, let's move on. So now we are ready to do something more interesting, namely handling events. So let's read the code together, starting of course from the main function. Immediately you see that I have this type MLX data that I call data. What is this type MLX? Well, this struct here, as you can see. I have this MLX data that contains the MLX pointer, namely the connection to the X server, the pointer returned by the MLX init, and a pointer to a window. Basically, a very simple struct. Why do I need a struct? You will see. So I init my connection, I create my window, and then what do? I call this function, which is MLX key hook. What is this function? Here, my friend, I suggest to you to watch this documentation, which is the best I found online regarding the minilibX. And we are basically at the section events. You can find the MLX key hook here. So let's read a little bit together. Events are the foundation of writing interactive application in minilibX. Basically, we have that every time a specific event is triggered, we have a response thanks to these hooks. The response are just functions that are called. For example, I press the space key, something is going to happen because I'm coded in that fashion. So I have a bunch of events that are allowed in the X11. You can see here there are many. Key press, key release, button press, button release. This is when you press the mouse. This is when you move the mouse over the window. 17 is when you press the X of the window when you want to close the window. So you have many events that can happen. Here, of course, you have the full documentation. Look at that. You have many events. So the idea is pretty simple. We have this function, for example, MLX key hook, mouse hook, or expose hook. We're going to only use MLX key hook now. As you can see from the documentation, every specific event has a specific prototype that gets called. In our case, we have key hook, which has this prototype. So int key code and parameters. You see, you have a void star parameters. Void star simply means a generic pointer. How does this translate to code? Well, I have my mlibx key hook with the window, the pointer to the function. So this is a pointer to function, as you can see. Handle input, the function is this one, handle input, this function here. And here I have the address of data, which is this struct here. So now you understand why I wanted to create this struct, because when I pass the data here, I want a big chunk. I want a container filled with variables that I'm gonna use in my hook function. So mlibx key hook. So here basically what is going to happen. Here is like I'm saying, every time you have a key release, this handle input is triggered, okay? So I want you to think in this fashion. I do all this code, I init all the X server communication, I create a window, and then I say, okay, I want to turn on this hook. Every time I have a key release, because this is what happens with mlibx key hook, you call this function handle input and you pass this data. I know that I have this specific prototype for my function that I created because it's written in the documentation. So the function is gonna be this one. Here it comes, handle input. I have the ksim and the data struct, okay, which is my object. And we're say if ksim is equal to escape, what do? You just close everything, you free everything, and you close the process. See, that's why I need a struct, because I need all the pointers here in the window and the mlibx connection. On the contrary, you just print the key that is being pressed, the ksim. Okay, let's watch the code in action. So I'm going to compile and launch. So I have my process, and every time I press a key, like now I'm pressing, when I release, boom, I have this that is written. Key 32 has been pressed. Now I press P, for example, I have that, A, and all the keys that I press, okay? Now what happens when I press ESC? Boom, I press ESC, and as you can see, the code ends. Let's do with Valgrind to check if we have some leaks. So now I'm gonna press ESC. As you can see, I don't have any leaks because I cleaned up everything. So what is this? It's K escape. Well, that, my friend, comes from this header file, ksim.h, which is part, of course, of the X11 server. If you search x11 ksim.h, you will find that it contains all these symbolic values. As you can see here, I have this one, okay, which is our case now. It's written in hexadecimal, but it is that value. Okay, here you have to understand an important concept, my friend, which is the difference between key code and ksim. Because a key code is a hardware-specific code sent by the keyboard for a key press, while a ksim is an abstract representation. Okay, what does it mean? Well, ksim are more abstract than key codes, so we can make code that is more portable because ksim abstract away the actual hardware. On the contrary, key codes are really tied to the keyboard. For example, if I press the letter A in a QWERTY or AZERTY keyboard, the key code is going to be different, okay, because the actual key is different. So the key code is really tied to the hardware. On the contrary, the ksim is much more tied to the symbol. So it is much more portable. Again, dig down into this topic. I just want to show you that for macOS, this is not the case. First of all, I have a compilation which is different, but you don't care by now. Here on macOS, I have key codes, as you can see. Indeed, when I press all the keys, I get these key codes. And when I press ESC now, I get 53, right? Which is very different from the value you saw before in the Linux, right? In the Linux system. Because in macOS, you get key codes. I don't know why, frankly, you're going to tell me. So in Linux, we are going to use these symbolic constants. Okay, let's watch very briefly another program. Essentially, I have the same init new window. Then I have this other function, which is mlibx hook. Okay, mlibx hook, which is basically this function that you can find here. Inside this function, mlibx hook, you can use directly this symbolic representation. In this case, I've used button press, which is number 4. As you can see here, we shall use also the mask, which is this one. And here I've written an explanation that you can check by yourself. But basically, what is going on? We have that the king function is the mlibx hook, but we have also APIs, which are more readable, maybe. I don't know. You see there? mlibx expose hook, key hook, and mouse hook. Okay, another cool thing I wanted to show you is this loop hook function. that you can see here. Basically, this function is cool because, well, let's running and let's watch it. So compile and launch, and as you can see, I get this result. Okay, I have this string that is constantly, right, shining different colors, but when I press, for example, space, it's gonna stop. Why is that? You see here? Okay, I'm gonna stop the code. As you can see, I have all the time the usual stuff, mlx init, mlx new window, mlx key hook. So every key I'm gonna release this function, f is gonna be triggered. And then I have mlx loop hook. This is new, right? And then of course at the bottom I have mlx loop that is gonna keep the program alive. So long story short, this mlx loop hook is cool because this is gonna be triggered when no events is gonna be perceived. So this change color is gonna be called constantly, you see? As you can see, this function is changing in rotation the colors of the string, which is at the center of the image, as you just saw. The thing is different when I press another key, right? For example, space. When I press space, this is what's gonna happen. I'm gonna sleep for 1 second. I'm gonna launch this function f, just to make it super visible that the blinking is stopping of the string. So this is another cool function that really allows you to make cool stuff, in my opinion. Mlx loop hook. Basically, no events listening. Okay, you can understand like that. Okay, now let's understand how I put a pixel in a specific position. So this is another program in which we're gonna check mlx pixel put. So we're gonna init, create a new window, key hook. In this case, we pass as an input data window, of course, key hook. So every time we release a hook, we are gonna trigger the f function, and then we leave control to the server. So let's watch the f function, what it's doing. The f function is checking for k-sims, of course. So we know that we use this symbolic representation for RGB, red, green, and blue. If R, we're gonna color the screen with the red color, otherwise we're gonna color with the green or with the blue, okay? Encode RGB is just a silly function that exploits bitwise operations. As you can see, it takes red, green, and blue, which are values ranging from 0 to 255, and then just shift them. So you have to perceive these like bits and not like numbers. And then it becomes super simple. Of course, my struct is always the same. I have my mlx connection and my window. And then I have the function color screen. What I'm doing here? Well, basically I'm saying for int y is minor than sideland. Sideland is just this value here, 800 pixel. Then I have for int x equals 0, x minor than sideland. So I'm basically looping in height and width, right? X is the width and y is the height. Okay, simple enough, a nested for loop. So for every point in the x, y to the window, I'm gonna put a specific color, okay? We're gonna call the function mlx pixel put, which is the function that is coming through the library. Let's try to compile and launch this code. Okay, I'm gonna launch. And now basically my program is listening to me, right? Thanks to this key hook. Is waiting for RGB. If I press R, G, and B, let's try. I'm gonna press R, and as you can see, the screen becomes red, green, blue, RGB. Okay, it is kind of cool. It works, but as you can see, it's kind of slow. It's kind of slow. I can literally see the pixels which are reading into the screen. It is kind of not cool. Indeed, this function really sucks. It is really slow. The problem is that it's not making any kind of buffering. It's just writing the pixel directly into the screen. What I really want is that I have the image which is ready, and then I want it to be pushed into the window. That's what I want. And indeed, I want an image. Keep in mind this. So let's move on. For this point, I have my pixel put, which is another function. Basically, it's a mlx pixel put, but optimized. To do that, we are going to exploit images. What are images? So think about that. You have the window where you see stuff, and then you have the image. Image is just like a buffer. Consider like a buffer. You are gonna create this image, and then you're gonna push this image in your window, only when it's ready. So let's read this code. This time I have my struct, which is slightly different. Indeed, I have this struct here. I have a pointer to the mlx connection, a pointer to the window, and then I have another struct, which is a struct image, this one. Here is where it is implemented. As you can see, it contains a lot of stuff. As you can see, I have a pointer to the image struct, then I have a pointer to the actual pixels, and then other data that you will see. So let's watch the actual code. of course, my mlx init, new window, and then I'm gonna call this new function, which is mlx new image. Okay, it takes as an input my mlx connection and the size. Of course, the image can be smaller or bigger than the actual window, but I just want to have an image which is the same size. I want to create it and then push when it's ready to the window. Then I have this other function, which is mlx get data address. And this function basically is filling all the data inside the struct. As you can see, I give as an input the image pointer, which is the one which is returned me by the new image. And then I give by reference, as you can see here, bits per pixel, line len and endian. Bits per pixel is like how many bits are inside one pixel. One pixel is one integer, so you have 32 bits. Line len is telling you the actual line len of the image, because it can be not equal to the actual side len. This is done for performance reasons, I will explain. And then you have the endianness. We don't really care about this data because you will see also that. As a return value, this mlx get data address is returning another pointer, but this is not a pointer to the image struct. This is a pointer to the actual pixels. So it is pretty useful because we are gonna manipulate exactly this value. Okay. Then the code is actually the same. I have my key hook and my loop. So we leave the control to the server. We have the function f that is basically doing the same thing as before. The only difference is that we have this new function, which is mlx put image to window. Basically is the thing of taking the image, which is buffered, ready, and push in the window. Think about sliding an image in the window. That's exactly the same idea. Then we have the function color screen, but here, as you can see, we have a big difference, which is that I'm not using mlx pixel put, but my pixel put, which is a function that I've created. And the function is this one. Basically, this is going to give a very big optimization in terms of fluidity of the program. Now I want to show you the actual difference between these two codes, slow, and this one I'm gonna do fast. Okay, so I'm gonna launch slow in background, so the code is running. This is the window for the slow process, and then I'm gonna launch fast. They are actually the same piece of code. The only difference is that in one I'm using an image in which I buffer all the pixels, and then I'm gonna push inside the window. In the other one, I'm using mlx pixel put, that is putting the pixel directly in the window. So watch the difference. Green, blue, green, blue. You see, it's remarkable, the difference. And this will, of course, pay its dividends when it comes to creating cool graphics, right? You don't want to be clunky like that. You don't want to see stuff moving so slow. You can actually see the pixels rendering, okay? So that's why mlx pixel put is kind of sucks. And we have to use the images. We are gonna write pixels inside the image and then put inside a window. Here I just have line len is equal to 3200. Indeed, the window is 800, so this is 3200, exactly 4 times, but this is not always the case because we have something which is called alignment. Here you have bits per pixel, 32. Of course, one pixel is one integer, so 32 bits. And here we have the value for endian that we don't really care. So let's understand better this my pixel put that is putting a pixel in an image. So this my pixel put is taking the image, right? The image struct that contains all this data. And what is doing? Well, first of all, is calculating an offset, which is an integer. How is doing that? Well, is multiplying y per line len and x per bits per pixel divided by 8. Basically, it's multiplying x per 4. You understand this point? Well, I think here you need some visual understanding of what is going on. Okay, so let's pretend we have an image which has side len 10 per 10. So an image 10 pixel per 10 pixel. We know that every pixel has 4 bytes, right? Because it is an integer. So our image is composed by an image pointer. This is a pointer to a struct, but more interestingly, we have this pixel pointer, which is a char star, of course. It is a pointer to 1 byte. So when I call the function mlx get data address, the return value is going to be a pointer to the first pixel, which is pretty useful. So here I have one pointer, as you can see from the image, to the first pixel. So let's pretend I want to color a specific pixel. What shall I do? I have to calculate the offset. How to find that? Well, I want to color the pixel in position x7, y4. Okay, so x on the x-axis and y in the y-axis, of course. So I have to say line len per y line len, and not simply 40 per 7. You see, I have a 40 bytes in 10 pixels, right? Well, because there is this alignment thing. Long story short, my friend, watch this video here, which is marvelously done. It can explain much better than I actually can what is this alignment thing. See, basically it's low-level performance optimization such that the code runs faster. I will leave a link in the description. Long story short, we can have line len, which is not exactly 40 bytes, but maybe more, you see? So it's always useful to use line len. So we have 4 per 40. So it's going to be image pixel pointer, which is a char star, plus 160. So this is pointer arithmetic. So I get that pointer plus 160. What is going to happen? Boom, it's going to happen that, right? The pointer now is going to point exactly for lines beneath, okay? Because I added 160 bytes to my pointer. How to find x? Well, I have x per 4, y x per 4. Well, because bits per pixel are going to be 32 divided by 8, I get 4. So x per 4, x is 7, so I get 7 per 4, I get 28 bytes. So let's see the animation. Now I have the pointer that is pointing in that specific byte. Okay, after that, what do? I cast this new pointer that I got to an unsigned int. Okay, what is an unsigned int? Well, this is a 1 pixel, you see. I cast to 1 pixel and I say, hey, inside that box, you just put the value ff0000, which is red, right? So what is going to happen is going to happen that the pixel is going to become red. That's what happens. Okay, so this code that you see is just to find exactly the pixel that I'm looking for. And that's all there is. So this function here is exactly doing that. It's searching for that specific pixel and putting the color inside that. At the end of the day, I'm going to have this function, put image to window, that is going to exactly put the ready image into the window. That's all there is. Okay, this is going to improve massively our code. So this is it for this gently, I hope, introduction to the minilibX. This is just another program that allows you to put a pixel in a specific point. For example, here I have xy 50/50. And as you can see from the code, I have this little dot here, okay? So you can play with this code to understand really what is going on. So I will push all this stuff on GitHub so you can play around, you can understand better what is going on. Of course, I don't go too much into details, otherwise this video is gonna become 100 hours and it's gonna become counterproductive. And yeah, that's basically it for this introduction to the minilibX. At the end of the day, you have to code by yourself, you have to understand by yourself. But we are gonna use these first principles that we got from this introduction to do much better stuff, much better project, and you will increase a lot in your skills. I promise you. Okay, thank you for watching, my friend. Enjoy.